Hi, I am Arib. You are watching my YouTube channel. Buchholz Relay. Definition. The Buchholz relay protects the transformer from internal faults. It is the gas-actuated relay. The Buchholz relay is placed between the main tank and the conservator. Such type of relay is used in the transformer having the rating higher than 500 kVA. It is not used in small transformer because of economic consideration. Working principle of Buchholz relay. The Buchholz relay working principle is very simple. Buchholz relay function is based on an elementary mechanical phenomenon. It is mechanically actuated. Whenever there will be a minor internal fault in the transformer such as an insulation fault between turns, breakdown of the core of the transformer, and core heating, the insulating transformer oil will be decomposed in different hydrocarbon gases, CO2 and CO. The gases produced due to the decomposition of transformer insulating oil will accumulate in the upper part of the Buchholz container, which causes a fall of the oil level in it. Fall of oil level means lowering the position of the float and thereby tilting the mercury switch. The contacts of this mercury switch are closed and an alarm circuit is energized. Sometimes due to oil leakage on the main tank, air bubbles may be accumulated in the upper part of the Buchholz container, which may also cause a fall of oil level in it, and the alarm circuit will be energized by collecting the accumulated gases from the gas release pockets on the top of the relay, and by analyzing them one can predict the type of fault in the transformer. More severe types of faults, such as short circuits between phases or to earth and faults in the tap changing equipment, are accompanied by a surge of oil that strikes the baffle plate and causes the mercury switch of the lower element to close. This switch is energized the trip circuit of the circuit breakers associated with the transformer and immediately isolates the faulty transformer from the rest of the electrical power system by intertripping the circuit breakers associated with both the LV and HV sides of the transformer. This is how the Buchholz relay functions. Construction of Buchholz relay. The Buchholz relay has two hinged, which is placed in the metallic chamber. This metallic chamber is connected through the pipe between the conservator and main tank. The one of the hinged is placed in the upper portion of the metallic chamber along with the mercury switch. This mercury switch is used for activating the alarm. The other float is placed in the lower portion of the metallic chamber along with the mercury switch. The mercury switch is used for actuating the tripping circuit. Operation of Buchholz relay. The internal fault of the transformer induces the arc inside the main tank. The oil of the transformer starts heating because of the thermal effect. The gas moves upwards, and few of their vapors are collected in the upwards area of the main tank. Because of the evaporation, the level of oil inside the transformer tank starts decreasing. The mercury switch placed inside the metallic chamber becomes tripped, and the relay gives the alarm to the personnel. The supply of the transformer becomes close, and it is disconnected to the system for maintenance. The relay has test cock which is used for releasing the pressure of the chamber. When the severe fault occurs inside the transformer, the lower mercury switch placed inside the metallic chamber becomes slightly tilted, because of which the tripping circuit becomes closed. Thus, the transformer is disconnected from the main circuit. Conclusion. Overall, Buchholz relay emerges as a crucial component for ensuring the safety of power transformers. This safety device assists in detecting potential faults that may occur within the transformer by monitoring the levels of gas and liquid inside. When issues such as overheating, gas accumulation, or leakage arise, the Buchholz relay comes into action, swiftly reacting to protect the transformer. Safety devices like the Buchholz Relay play a vital role in the efficiency, durability, and reliability of transformers. They contribute to ensuring the security and continuity of power systems while preventing possible faults. It is essential for the Buchholz Relay to be designed and tested in compliance with industry standards.